This is another problem from the group teaching circular motion set that we went around in groups, in 7 groups, and solved 7 different problems. It's off the circular motion practice problem sheet for College Physics 12. Now this is a motorcycle, but I'm going to show you a video. You should pause, rewind, read this, write it down. But I'm going to show you a video that's not a motorcycle, but it illustrates the forces very nicely. Now this video shows a car going around in a circle. It shows that there are multiple forces on the car. However, you're most interested in the force that is actually making the car move in a circle. That is the centripetal force, and that is the central question. That is what we kept going back to on every one of these problems, which was, what is the force that is making this object move in a circle? As you watch this, you can see that there's a force directed toward the center, and if that force were suddenly removed, this object will go in a straight line. It's the force toward the center that is making it move in a circle. And more specifically, in this case, it is a frictional force. It's not always a frictional force. Sometimes it's a gravitational force. Sometimes it's a tension. Sometimes it's a normal force. Sometimes it's a combination. In this case, it's a frictional force, which is key. So that frictional force is what I am going to put in this diagram. It's always good to just draw a picture, and I will actually require this on the quiz for some problems at least. It's good to draw a picture, draw the force that is actually making the object move in a circle, in this case a frictional force. So I'm writing F sub F. And the central question, as always, is what forces combine to make this object move in a circle? What are the forces that are making this object move in a circle in this particular case? And in this particular case, well, in every case, you should write down F sub C is equal to mv squared over r. And that question that I just posed is really addressing this right here. It's addressing the centripetal force. So instead of F sub C, what can I write there, Henry? We're getting, he jumped ahead a couple steps. He said mu m times g. But what you were just referring to is the frictional force. So I'm going to write down F sub F equal to mv squared over r. So I'm writing down that the frictional force is equal to mv squared over r. Then you look over on the board and you see this equation for frictional force, and it's got some information in it. So you write down that equation for frictional force. And in place of this, I'll put the equation for frictional force. So I just write mu times the force normal is equal to mv squared over r. Now here's the part that we have to explain a lot and take some visualization. This is the key to the problem. It says on a horizontal curve. When something is on a horizontal surface, we know that force normal is equal to the force weight, which means it's equal to mg. Again, when something's on a horizontal surface, if you think about it, the normal force upward, and this was shown in the video. I'll show you the video again real quick. This was shown in the video that the normal force upward is equal to the weight. That's a perfect shot of it right there. So I'm going to put in mg instead of force normal. I'm going to put mg because right here, because they're the same thing. So I write mu mg is equal to mv squared over r. And it seems like I needed the mass, but I don't need the mass, because the masses cancel out. You are not given the mass, and you will do, if you try to jump in and do stuff with numbers, you're going to get lost and you're going to get frustrated and confused. Trust me, jump into the equations and you're going to see that this is the key step. And when you continue that key step, you will see that the masses will cancel. Now I'm going to do that thing where I don't go through and solve all the algebra. I'll just say we were given the coefficient of friction. We know g, it's 9.8. We know the radius of the turn. And then we can answer the question, how fast by just solving for V.